So in this video, a little bit about organic chemistry. So we're going to do the organic chemistry basics, the rules for naming or nomenclature. I'm going to tell you about the different kinds of organic compounds, and then just a little bit of biochemistry, some of which you've already had. All right, so when we're talking about organic chemistry, we're talking about the chemistry of carbon. So all of these molecules contain carbon, primarily carbon and hydrogen, and so we call them hydrocarbons affectionately. And so what do these include? All kinds of compounds that you are in contact with every day are what we would call organic compounds. They're containing carbon. And so carbon is a very unique atom. As you know, it is in group 4 on our periodic table, which means it has 4 valence electrons, and so it enters into 4 shared agreements or covalent bonds with other atoms. And it has to have those 4 covalent bonds in order for it to work. And so this makes it very unique. And so carbon can form long chains, can form branched chains, and even rings. And so what are some of the characteristics of these organic molecules? First of all, of course, they are molecules because they are made with covalent compounds. They're typically nonpolar because if you take a look at the electronegativity of carbon and hydrogen, there's not a very big difference between them. Typically, often they do not dissolve in water. And so the only intermolecular force that would cause them to stick together would be London dispersion forces, unless they have oxygen in them. And then when they have oxygen in, that area of the molecule is going to be a little bit polar and will even dissolve in water and may be attracted to water molecules. So they typically, because they're covalent, have low melting and boiling points. They're also typically flammable. And they can form isomers. Because of their sort of complicated structure, these carbon-hydrogen compounds can arrange themselves in different ways, forming isomers. So those would be the same formula, but different shape and so different properties. All right, so if we take a look at this, if we collect all the hydrocarbons together, we can kind of divide those into 3 groups. Carbon compounds that make a chain are called aliphatic compounds, not carbons, but aromatic, which are going to make rings. Notice that this ring, this hydrocarbon aromatic, is every other bond is a double bond. And then we have some specialized or what we call functional groups. And so we're going to talk about each of these types of organic molecules today. And so the first thing you kind of need to be aware of is if you take a look here, we have 2 different carbon compounds. If we take a look at the unsaturated compound on the left, notice that because of that double bond, there aren't as many hydrogens as there could be. If we were to break this double bond or put a hydrogen in, then we would have more hydrogens in this molecule, and then that would have to be a single bond. And so we would call that unsaturated. That molecule, those carbons are not full of hydrogens. But if you look at the molecule on the right, that molecule C2H6 is full of hydrogens. Every carbon has the maximum number of hydrogens that it can have. And so as we look at these carbon chains, we can have 3 different kinds of carbon chains. We have alkanes, alkenes, and alkynes. Alkenes, all the carbons are bonded by single bonds. Of course, hydrogen can only have 1 bond. I often use my honk rule. Honk 1, 2, 3, 4. Every hydrogen has 1 bond. Every carbon has 4 bonds. The alkenes, are a little different because there's at least 1 double bond in the alkenes. And so they take the formula where whatever your number of carbon is, you have twice as many hydrogens as that. And then we have the alkynes where there's at least 1 triple bond. And so as we look at how we name these molecules, we do have some rules and we're going to practice those. We use the IUPAC naming system. so that way everybody's naming them the same. And so we're going to take a look at these molecules, look at the longest chain, any items coming off of that longest chain that are anything other than a hydrogen. And so here's the naming rules. Again, look for the longest chain. Look for anything's attached to that chain other than a hydrogen. Number each carbon in the chain, starting where you're starting from one end or the other, and we'll practice that. And then look for any side groups and then assemble the name. And we use prefixes and suffixes to name these compounds. Now, if you take a look here at the bottom, you're going to need to know the number of carbons and those prefixes. You're going to also need to know the endings or the suffixes, depending upon if they're single bonds, double bonds, or triple bonds. So you might want to snap a picture of this and keep it handy. All right, so let's take a look at some examples. All right, the first molecule, 1 carbon. So that's the prefix meth, all single bonds. So we have methane. The second molecule, 2 carbons. So the prefix is eth. Again, we have all single bonds. So it's ethane. The next molecule, 3 carbons, only hydrogens hanging off of those 3 carbons. So it's prop and then ane, propane. Take a look at our next molecule, 4 carbons, all single bonds. Bute is the prefix for 4 carbons, so this is butane. And so if we take a look here, at the molecules on the left, these are just linear molecules, no branches coming off. But if you take a look at the molecule on the right, this is basically the same molecule, but we've replaced the hydrogen here and here with this carbon group. This carbon group has 1 carbon, so you're probably thinking, oh, prefix meth. You're exactly right. And so we're going to name that based on the number of carbons in the longest chain and those branches coming off of the molecule. So there's a couple of ways that we can write the notation. So if you take a look here, the molecule at the top is an alkene because we have at least 1 double bond. The molecule at the bottom is an alkyne because there's a triple bond. And so we're going to prefer to draw the molecules as we have on the left, but you should be aware that they can condense the notation for these so that you can see how those work. And you can, and the location of the double and triple bonds. But you can see if you just had the formula for these molecules, like C3H4, that's not really going to give you a lot of information about the molecule and its structure if you needed to build it exactly like you see here. The other thing we can do is a skeleton notation, and we will use this some. So if you take a look at this molecule at the top, so we have 1, and I'm just going to number them here from the left, 2, 3, 4, 5 carbons. So when we do a skeleton notation, you can see that at each bend of our skeleton, in the beginning and the end, those are the locations for these carbons. And the same thing with the alkene with the double bond below and the alkyne with the triple bond. And so you can see how that works. All right. In addition to some functional groups like CH3 or C2H5 hanging off of the longest chain, there can also sometimes be a halogen. That would be one of our group 7 nonmetals. We call that group whatever the element is. If it's chloro, fluoro, bromo, we add an O on the end. If our side chain has 1 carbon, that's a methyl group. If it has 2 carbons, that's an ethyl group. and so forth, using the same prefixes that we looked at earlier. So let's take a look at this molecule. Can you name it? So what's our longest chain? Well, I see 1, 2, 3, 4, 5, 6, and then this one with just one carbon. So our longest chain is 6. So that prefix is hex. The next thing we're going to look at is the bonds. Single bonds, double bonds, triple bonds. All single bonds. So it's hexane. Now we're going to look for anything hanging off of this molecule that's not a hydrogen. And you can see that we have this methyl group right there. There's only one carbon, so that's why it is a methyl group. All right, and so now we're going to take a look at how we're going to number this molecule. We can number the carbons like this. 1, 2, in the longest chain, 4, 5, 6. So we need to think, okay, do we want to number it from the left or the right? So this is numbering from the right. If we numbered from the left, right over here, and the only thing we want to take a look at is we want to look at our side chain, our branch. And we want to number it in such a way that it is going to have the lowest number in front of it. And so as you can probably see, we want to number with the red numbers from the right. And you are exactly right. Because what we want to have is we want the carbon, the branching chain attached to the lowest number carbon. And so what do we call this molecule? Well, we know it's hexane, but because it has that CH3 group hanging off of the number 3 carbon, we're going to call it 3-methyl hexane. Let's have you practice these two molecules. Again, same procedure, longest chain. We're going to do the one at the bottom first. Notice that our longest chain was 1, 2, 3, 4. Oh, sorry, that's 3, 4, 5, 6, 7, 8. So that's oct. And because we have all single bonds, it's octane. And then we're going to decide which way to number it. We want to get it so that our branch chains are the lowest number. So obviously we don't want to number it from the left because that would be higher numbers than from the right. And so we're going to number this one from the right. So that's going to be 1, 2, 3. So this is going to be 3-chloro, 1-methyl, octane. And so we also put our branching groups in alphabetical order. See if you can do the one above. Longest chain, branching groups, number the carbons, put the groups in alphabetical order. So did you come up with 1-chloro, 1-ethyl, 1,4-methyl pentane? Oh, and I think I should have had, I believe we have an arrow here. So there's my 1-chloro, 1-ethyl, 4-methyl. Nope, that's correct. 4-methyl pentane. So that is how we name these molecules. All right. Okay, so let's see what you can remember. The aliphatic hydrocarbons, if they're saturated, yes, those are our alkanes. If they're unsaturated with double or single bonds, double or triple bonds, alkenes and alkynes. If they're in a ring with every other bond being a double bond, those are our aromatic hydrocarbons. And then some of our functional groups that we still have to look at. Ether, ester, aldehyde, ketone, carbonyl group, carboxylic acid group, alcohol, amide, and amine. If the group has sulfur, it's called a thiol group. Again, these carbon compounds, these hydrocarbons can form rings. Of course, just 3 carbons, the smallest molecule that could be rings. So we often put cyclo in front if it is in a ring format. And of course, benzene is one of our most famous rings. It's one of the additives to gasoline. Why you can't have your children pump gasoline with you, because they're right at nose level where the benzene would be exiting the pump. All right, so now functional groups. Functional groups are super cool because they really give these organic molecules some of their sort of personality. They are associated with smells, and you need to know the functional groups, but you don't have to know the endings. I do have those there, but like I said, you don't need to have those, know those. You just need to be able to recognize the functional groups. So here they are. The first functional group is an alcohol group, also called a hydroxyl group. It's simply when you have OH hanging off of a molecule. So instead of an H, you'd have an OH. If that H is removed and replaced with a C, we call this an ether group. I remember this one as the ether bunny. So here's my little bunny. Here's his ears to the side. And so that is our ether bunny, our ether group. A carboxylic acid, or carbonyl group, and then we'll go into carboxylic acid, is C double bonded to an O. If it goes COOH, then it's a carboxylic acid. If the C is double bonded to an O with an ether, it is then an ester, not an ether. Our aromatics contain benzene, which are 6 carbon rings. Every other bond is a double bond. NH2 would be considered an amine group. Now, if that amine group is next to a carbon double bonded to an oxygen, it is an amide group. And so here's just some pictures of these functional groups so you can kind of see what they look like. The R in each of these cases is just the rest of the molecule. Carbon-carbon chain, a hydrocarbon, double bonds or single bonds. Again, you don't need to know the ending or the group name. You simply need to be able to recognize them. So when I've learned these before, I simply made flashcards for these. Here's another view of the same thing. This one, no, this one didn't come from your book. All right. Take a look at these functional groups and see if you can identify them. Of course, that's an aldehyde. Take a look at this one. Yep. Hopefully you were thinking that's an alcohol. How about this one? Yes, that is an aldehyde. C double bonded to an O. We've got a ketone group here. That's C double bonded to an O with the carbon continuing in the opposite direction. Ooh, COOH, that's our carboxylic acid. Here's some more. Can you identify these? All acid groups, obviously. Obviously, this is vinegar, acetic acid. Now, of course, these molecules can get more and more complicated. And so what you're going to be doing is taking a look at the molecules and seeing if you can pick out some of the functional groups. Naming the simpler ones, not ones like this. And so you want to be able to take a look at this and pick out some of the functional groups. So as we're taking a look right here, hopefully you figured out some of the functional groups. So part of our molecule here is cut off. This, of course, is the molecule nicotine, but here's an amine group. Here's an amide group. Of course, we've got a bunch of methyl groups, but they wouldn't really be considered functional groups. Here's an alcohol, that OH hanging off there. Here's another amine group. We've got an aromatic ring right here. If we take a look, let's see. So this would be a carbon with a bond to oxygen and then bonded again to carbon on the other side. So technically, as we're taking a look at this, this would be an ether group. And that's about all I see here without repeating some of the groups that we've just done. So some of the different molecules, there they are. You've probably heard of many of those. Now, if we were to take a look at a molecule like this, here's how we would name it. And so a lot of these organic molecules have sort of common names. This is Zithromax that we would call that. All right, so on to biochemistry. And in biochemistry, we're simply going to take a look at the biomolecules. They're also macromolecules. Because they're large. You already know about carbohydrates, lipids, and proteins that our bodies use for energy. And probably you've heard of nucleic acids, which help to store information for our cells. We have both DNA, deoxyribonucleic acid, and RNA, ribonucleic acid. Just a couple quick things you should know about our carbohydrates is these are rings. Now, this isn't a benzene ring, but these do form ringed structures. And as we're looking at carbohydrates, one ring would be the most simple type of carbohydrate. If there are and it's called a monosaccharide. If there are two rings bonded together, that would be a disaccharide. And then multiple rings bonded together would be a polysaccharide. And again, our body uses this as our main source of energy. We take these more polysaccharides and break them down into monosaccharides for energy. And glucose, blood sugar, is a monosaccharide. Lipids, you can see a little bit more complicated structure here with lipids, and that's why they have so much more energy. Now, typically our lipids look like a letter E. So we have a glycerol background that looks like this, and then fatty acid tails joined to this letter C, which is why sometimes our fatty acids are called triglycerides. And depending upon this hydrocarbon chain, it could be saturated. Every carbon is full of hydrogens, or unsaturated, where some of the carbons have double bonds. And so you probably buy your fats based on that idea of how many carbons are in the molecule. And then, of course, we have proteins. Proteins are they are macromolecules. They are made up of amino acids, long chains of amino acids. And if we have a shorter chain of amino acid, it's called a polypeptide. These are the items in our food that our body prefers to use for growth and repair. It can use it for energy. You know it has 4 kilocalories per gram, but it's not our body's first choice. All right, and nucleic acids, DNA and RNA. You can see the difference between DNA and RNA is that RNA is single-stranded, DNA is double-stranded. And they have bases that are joined together. And so we do have some slightly different bases. Instead of adenine, thymine, cytosine, and guanine, RNA has adenine, uracil, cytosine, and guanine. In our DNA, A always goes with T, and C always bonds with G. And so one of the things that especially restaurants do with fats is hydrogenate them. So they break some of these double bonds or triple bonds and to change the texture of the fat. This is how they created something known as, that you've probably heard of, called trans fat. Often these fats are unhealthy when they're changed. All right, so I'd hope to get to this on Tuesday, but we didn't. So hopefully you now, if you've watched the Zoom from Tuesday, you know more details about the lab 10B and your lab report. Hopefully you know the 3 types of radiation. Hopefully you feel comfortable writing nuclear equations and calculating half-life. You can also now identify organic compounds and hopefully name them using the IUPAC rules.